Thank you very much. As he said, my name is Neil Rogers, and I'm a professor of electrical and computer engineering at the Air Force Academy in Colorado Springs. And I really wanted to get up and talk about how we've taken some of the applied software-defined radio concepts and moved them into our theoretical class, which I think is providing a great benefit to the students. And I have to say from the get-go, like, just being at these conferences has really kind of inspired this work. Being a part of the Capture the Flag challenges, meeting people like Mark Lichtman and Marcus and all the people that have to do that do work here with GNU Radio has been a great inspiration for me. So I'm going to kind of dive right in. You have to know that even though I work for the government, I don't represent the government. There we go. So what we're trying to do here, jokingly, right, is make undergrad comms great again. We all kind of took an undergrad comms class and we walked away and we said, okay, I know how to calculate this power spectral density, I know Parsifal's theorem, I know the Wiener-Khinchin theorem, right, and I know how to do that math, but so what, right? And then we walked away and we thought, well, I don't really have time to study this again. So what I'm trying to do is really accomplish 5 objectives. The first is to generate renewed interest, right? Communications, especially from a military perspective, is going to be something that we have to think about a lot. We have to be able to provide communications while hopefully denying it to our enemies. So this is something that I want my cadets to be interested in, but they're not when they walk away from the old version of this class. So how can I generate that renewed interest? How can I take the curriculum and modernize it so that we incorporate some of the topics that, especially the things that we talk about, like the research that's happening at the graduate level, right? If we want to generate interest and generate kind of a pipeline where we're motivating students, we need to have modern topics. Of course, I want to be the best possible teacher that I can be, and so I want to implement the best practices of pedagogy as I go. And then I want to maintain a strong theoretical foundation while I do that. So I don't really want to get rid of that theoretical foundation because that's important stuff to know, but I want them to be able to tie that to the real world. And the way to do that is by implementing hands-on learning, just like we heard from our SETI friends earlier today who talked about that, right? And the compelling questions that we can get them to ask in the presence of software-defined radios, I think, are the things that are going to help us accomplish all of these things. And really, in the end, I want to build spectrum-aware technical leaders for the next generation of my Air Force and of our military, and then of our commercial sector, who are going to continue to help do things like develop SATCOM radios. Right? I just heard that the new iOS has a SOS feature that uses SATCOM radio, which is super awesome, that you can phone home from your iPhone. Even though I don't have an iPhone. Okay, but a caveat first, right? So I feel very much like an imposter. I inherited this course sequence because we had a professor who retired, like 2 weeks notice over Christmas break, and they called me and they said, Neil, you're up. You can spell RF, so you've got all his classes. So I got EMAG, I got the comms class, both the comms classes, and away we go, right? So in some ways I feel like an imposter, but I also feel like that helps me think a little bit outside of the box. Like, hey, I know we've done this way in the past, but what are some new things that we can do to get away from that to help students be more engaged, right? And so those are the questions that I'm asking. And so when I ask myself, like, how did I find myself here? Really just kind of by coincidence and by the fact that I was there when nobody else was. Okay, so I thought I'd take maybe a little bit of a break here and tell you about USAFA, right? It's not your typical four-year school. The cadets show up, and within, like, the day they show up, they look like this, right? They go through an intense physical and leadership training program, starting with a 6-week basic training before they even see me, right? And they don't see me till their junior or senior year when I start to teach this course, but it certainly shapes their framework and it shapes their mental model about how to learn. In addition to that kind of that introduction to the military, then they take on a really rigorous academic program that consists of probably a more extensive core sequence than any other university that I've been at. So they take something like 90 credits of core classes. And that includes everything from English to basic electrical engineering to computer science, right, philosophy. They have a ton of core classes that they have to do. So they're always crunched for time, always crunched for time. They also, while they're going through that rigorous academic sequence, they have some military training that they're doing on the weekends and in the evenings. And And by the way, all these pictures I just pulled from the use off of Flickr, right? So these are all like public domain things. Really cool to go in there and look, and you can see what me and my cadets kind of go through on a daily basis. So in addition to academics and military training, as if that wasn't enough, they have athletic requirements that they have to meet. So this is a picture of my CrossFit team that are competing against Army at the time, and Army won, unfortunately. All of that goes to say this is kind of what their day looks like. You can't see this, right? But they have a block schedule, so we have M&T days or A and B days, and they're scheduled from 05:30 in the morning or 06 in the morning until 2300 at night. So they are busy, busy, busy. So while I'm asking these questions about the comms classes, I have to think about what they're doing that have nothing to do with my class. Because if I make this class too intensive or too hard, then I'm certainly affecting other parts of their lives. But that's not to say I'm making it easy, right? That's not to say I'm making it easy at all. In fact, the thing that I want to do is keep the difficulty while raising the level of engagement, because when they care, that's when they're going to put forth the best effort on it. Okay, so we're really talking about two comms classes here. The sequence is our Introduction to Communication Systems, which is going to be, which is going to be our ECE 447. So I'm going to continue to reference these by class number because that's easier for me. And this is the first in the sequence that they would take as a senior during this semester, their fall semester. So I've actually got cadets that are in class right now taking that class. And here we're trying to give them just the theoretical foundation. And this is the class that I think probably benefits the most from our reorganization that we've accomplished. And then the second class was really kind of divorced from that. And the second class was an application of software-defined radios, where we start to look at GNU Radio and how can we use GNU Radio to teach them about real-world signals? And really what we end up doing is just kind of teaching them an introduction to software-defined radios as a whole, because we couldn't get too deep into it. And I'll explain that here coming up. So if we just take a top-level look at the two syllabi, right? So these are kind of the main topics that we hit as we go through the courses, and this is before we did the reorganization of the class, right? So this is kind of what I walked into. I walked into the situation where we've got, on the left, 447 has a bunch of topics that look familiar, and probably to you, you go, yeah, you need to know that, right? And it's true, you do need to know that. We need to understand Fourier, and we need to understand amplitude and angle modulation, right? But the two kind of pinkish red topics, that's the only place where they actually put their hands on equipment. Two labs, maybe three if we got lucky. And those were like an AM lab where we measure the modulation depth, and an FM lab where we do the same thing and we measure the power in the sidebands, right? So, and then the digital modulation lab where we might take into account the effect of noise on your probability of error, right? So those are cool topics, right? But you're looking at a key site, you're looking at a function generator, you're looking at a signal generator that's doing the modulation, right? You've got this, $50,000 worth of equipment on the table, and that's certainly a different situation than maybe if you're sitting overseas somewhere worried about electronic warfare or looking at the spectrum, which are the kind of things that I'm trying to prepare my cadets for. So the right-hand course, the one 448, looks pretty good, right? Lots of hands-on activities. We're doing lots of things with GNU Radio. They're engaged. And so I'm pretty happy with that. But there are some challenges. And so I'm going to kind of talk about the challenges with each course right now. So again, with 447, just really 2 or 3 hands-on activities. And that gives very few lessons where we're able to give them concrete applications of communication systems. And minimal connection with the next course, right? So in fact, the first course wasn't even a prerequisite for the second course. And so if I'm going to make a course sequence, I should probably try to tie those together as well as I can. And then what that resulted in, right, was just an over-reliance on theory and cadets that ended up having, as much interest as getting off the couch as my dogs do. So, which is to say not very much. And the result is, right, we have graduates that are kind of lacking. They have gaps in their experience and their education. So now if we switch over to the other side and we take a look at 448, right, again, I'm pretty happy with this sequence of things that we're teaching them. We're starting to look at some representative modulation types that we're maybe more interested in, more relevant. But I end up teaching a lot of lessons just troubleshooting the hardware and the software. Like, what's the buttonology of GNU Radio? How do I create a flow graph, right? What are the data types that we have flow through it? And what are the implications of using complex data versus real data, right? We have to kind of teach all of that stuff, and that can get in the way sometimes of the cadets, you know, backing up and looking at the modulation. Hey, what is this signal actually trying to tell me? And so again, I have really little room to give them experience in real-world signals. And they struggle with their final project, which is supposed to be an applied project that they get to pick and they get to define and they get to build whatever they want to build. But they don't have the tools to do it. They don't have the kind of intermediate skill set that I need them to have in order to do that. So again, the end result is I've got graduates who have gaps in their education and their experience with regards to real-world signals. Okay, so going back to my goals here of addressing the issues, if I want to generate renewed interest, right, how can I do that? Well, I can bring software-defined radios in earlier. I can bring them in earlier to the sequence. Okay, well, how do I modernize it? Well, we want to look at real-world signals. Okay, if I want to improve my pedagogy, I want to give them a hands-on experience. I want to have them, you know, putting their hands on equipment and really receiving signals and doing the demodulation themselves rather than just learning theoretically about how to do it. And at the same time, I want to keep that strong theoretical foundation, and so I need to identify the core material. Here's the stuff I absolutely need to keep and teach them, and then try to make some room for that applied stuff, so that they can make every class interactive and apply that hands-on learning. Okay, so we're gonna do that. We're gonna make the classes great again. So here's again a view of what I walked into, the previous situation, and when we make it better, we kind of look at how we can reorganize that. Here's what the situation looks like. So you can tell right off the bat that there are many more applied lessons in our early class, right? So I've taken some of the introductory software-defined radio material from the second class and pulled it into the first. In fact, we're on lesson, I think, 14 today, 14 out of 40, and our cadets have already installed GNU Radio and built their first flow graph, right? And so, as opposed to not having done that until late signals, right? And so now the lights start to come on, and we can listen to AM radio, and we're lucky. We have an AM and FM radio station that broadcasts right down the hallway from us. You actually can't hear it from my classroom, but we can get plenty of radio stations in there. After we do that, we're going to go back into some theory for angle modulation, so we're talking specifically about FM here. And we're going to do another lab where we, again, put them on the benchtop traditional lab equipment, and then we're going to turn around and we're going to do it in GNU Radio, right? So you see this theme of like, teach the theory, do the lab, then do it in GNU Radio. And what I'm trying to do is tie those three threads together so that they really trust what GNU Radio is doing behind the scenes, so that when I give them a flow graph and say, no, this is really going to help you demodulate this thing, they actually trust that it's going to work, and they have some idea of what's happening behind the scenes. So we do GNU Radio FM, and then we have to talk about noise. This is kind of an ABET thing, but it's also important, right? Noise is everywhere. It can cause interference, pass interference. I guess I'd laugh at my jokes. I know it's the afternoon, but it's funny. All right, and we talk about probability of error, talk about bit rate errors and things like that. And then we move on to digital modulation, things like ASK, FSK, PSK, and they do a lab where they kind of measure the bit rate error from a pseudo-random sequence. And then they're going to take that and, yep, we're going to do it in GNU Radio, right? And I haven't even really called out where all the curriculum that I do the GNU Radio stuff comes from, but like Barry has done a tremendous job of building up the GNU Radio tutorials, and there is no reason for me to rewrite that stuff when there's excellent resources available. So I literally pull up the GNU Radio wiki, and I say, away we go. And I start to kind of fill in the gaps and help them walk around and help them build these flow graphs so that by the end of the class, they actually all have it kind of up and running. So we build the FSK tutorial, and then I say, okay, the FSK tutorial kind of stops at like, we've recovered the original bit stream. But then I want to take it a step further and say, okay, now I want you to develop a decoder to take that bit stream and turn it back into ASCII. So we start with ASCII, we do the modulation, the filtering, we do the transmission, we have a noise source, all of that, and then we do the demodulation, I want to have them do the decoding, and usually they'll do it with the ZMQ sync off board. And that teaches them a whole lot about what GNU Radio does with its data flow, right? You get these lists of arrays, and they're ones and zeros, and what the heck do I do with them, right? So we teach them how to process the data that's coming out of GNU Radio and how to interpret that, right? How to take a look at that data and say, okay, this is what that actually means in the real world. And that ends up being a really great project. Well, then I have to do a final exam because the Air Force Academy says I have to do a final exam. So it's comprehensive. And oftentimes what I'll do here in the final exam is I will, I'll put in some flow graphs and I'll have common errors, right? Sample rate mismatches between blocks, blocks that aren't connected, right? Things that they should kind of pick up along the way. And that's my way of testing to make sure that they have GNU Radio literacy, because when they all decide that they want to take the next class, we're going to pick up right where they left off. In fact, we're going to start right with that, one of the modulation techniques that we talked about in detail in the previous class, and that's how they get their syllabus. So they actually have to demodulate and decode their syllabus, otherwise they can't start the class. And this is a whole lot of fun, right? In fact, I had some cadets that were like, okay, this is really cool, but I don't get it. And I was like, okay, well, you weren't, I guess they lose everything over Christmas break, right? It's what students do. But a really cool way, I think, to kick off the class and say, no, we're going to be all about applied communications in this class. And we have to do some things like talk about signal space and talk about different kinds of, antipodal signals and things like that. So we do that kind of at the get-go, talk about noise figure and link budgets, because those become important when like, hey, why can't I talk all the way across the room, right? It's because of the link budget. And then we're going to jump into the excellent paper that Dr. Mathis from UC Boulder wrote. I think it was like 8 years ago at this conference, and I still go through it in detail because he gives such a great treatment of how you can kind of unpack things in GNU Radio and use them in terms of match filters, in terms of how to create, serial to parallel or parallel to serial conversion and things like that. So I walked through his paper, and every single one of these projects that we're going to do has a homework assignment tied to it. And the homework assignment isn't tell me why. No, it's take what we've done and extend it further, right? Make it better or do something else with it, because that's the starting point. And inevitably, I found that the cadets respond really, really well to that type of teaching. So after we do the PAM, we're going to talk a little bit about out-of-tree modules and how you build them and how you use them and why you might care. Turns out this is kind of hard to do in Windows, right? As great as Radio Conda is, VS Code is worse. And so we have a hard time getting things sometimes set up in the environment. And all my cadets come by default with Windows, so I have no way to kind of get away from that. And then we'll start to dive into some custom signals. Some things like CW, where we're gonna take Barry's CW generator, and we're gonna have them build a decoder. How do we decode CW? And then we actually I put up my phone, which has a CW app on it, and I start to send messages, and hopefully they can receive those through their GNU Radio decoder. And then we're going to take a look at things like HD radio. So I think Vlad was in the room. He created a great challenge last year as a part of the CTF that had wideband FM. And so we take a look at that and what you can do with digital sidebands as opposed to the analog, main band. We take a look at ADSB and AIS, because these are real-world signals that make use of incredibly simple modulation technology and are really effective, right? If you look at the low power of ADSB, blows my mind that we can actually transmit that, and we rely on planes to not fly into each other because of that, right? That's pretty impressive for me, so I like to dig into that a little bit. And what I'll do here is I'll actually give them some exposure to the standards, right? We'll pull up the standards document, we'll look through it, and we'll pull out the relevant information about what the modulation type is, what the pulse length is, right? What the power needs to be, all these things. And then they start to hopefully tie these concepts together, that they're not just blocks on a page, right? But they're real-world components that are creating signals that we need. Okay, we'll do DTMF because it's fun, and it's always fun to have 8675309 pop up as the answer. And then we'll take a look again at the excellent MPSK tutorial on GNU Radio's webpage, and this is great to talk about pulse sampling and timing. and synchronization and multipath and how you use equalization, right? All of those blocks, this is a fantastic opportunity to do that. Move on to FHSS, where I'm using, I think the user is Solomon on Medium, wrote an excellent kind of write-up on how you would build an FHS frequency hopping generator. And my friend Sandia in the back have a lot of good things to say about de-hopping, so we can think about that for the cadets and their final projects. We'll do some reverse engineering of an on-off keying fan remote that you can buy from Lowe's. It's really neat to take a look at this and see what we can find out about the waveform and whether we can recreate it. And their project is actually to turn the lights on with a hack RF. And most of them end up doing it, which is really kind of neat to see. And then we do fun things, right? Like take a look at the SIG-ID challenge from a couple of years ago. This has a lot of great signals buried in it. It is a great opportunity for them to practice those topics. And kind of the last thing that I want to talk about is their final project, right? So in this final project, they have the opportunity to define what they want to do. So they give me a proposal around midterm that says, here's what I want to do. And I come back and say, whoa, that's going to be way too hard, right? That's going to be way out of your range. Let's not do that, so let's scope it back. Or I say, no, you can't build an AM generator, right? That's way too easy. So I try to get them to scope it appropriately, and then I have them give me a little bit of background research, and then they have to come back a few lessons later with a prototype description or a design description, and then they have to finally present their work at the end of the semester in a presentation and a final report. And so what I'm getting them to do with these milestones is build up almost a publishable paper that they could say, okay, now I know how to write a paper. I know how to do research. I know how to scope a project. I know how to describe a design. And I know how to test and verify that things work. And so by the end of this, it's a whole lot of fun. So a couple of cool examples. I had a cadet last year that took GR-NTSC and actually fixed it to work with PAL. So we can do PAL. I got 5 minutes or I'm done. Okay, cool, thanks. So we can decode and demodulate PAL and NTSC with the same blocks. And in my world, there's a whole lot of use for this kind of technology. So I was really excited when he was able to pull off the PAL demodulation on the bottom. I had a cadet that recreated a PPM-based RC controller. And he was able to take an Xbox controller, link it into his computer, have GNU radio, take the input of that, and then broadcast the proper PPM signal to make the thing move left, right, up and down, which was really cool. And then I had a student last semester that kind of did the NOAA imagery, right? And yes, this is built into a lot of software packages, and he used that, but the hard part of this was he built his own antenna. So he built his own antenna, and he realized that the antenna didn't work so well on our terrazzo, which has a bunch of rebar underneath it, right? So he took it out of our environment and took it to basically a forest in the middle of nowhere and was able to get a clear line of sight for the satellite overpass and was actually able to decode the signal. I told him at the beginning of the class that I didn't think he was going to be able to do this, and he pulled it off. And so it's a lot of fun to see cadets kind of take those tools and say, okay, now I believe what I'm getting out of them, and I kind of know how to work with them, right? These are the kind of cadets that I want to be sending into the Air Force that understand what the spectrum is, especially when we start thinking about drones and we start thinking about communications being denied or GPS going away, right? Those are the kinds of things that really keep me up at night and the things that I want my cadets to recognize what's happening when it happens. Okay. So how did I do, right? I don't have any formal feedback because I've really only done this for one semester, but the feedback has been great, right? Our students say, my students say, yeah, that was one of the best classes we took. In fact, after I gave the CTF challenge for their midterm exam, I gave it to them over a weekend and said, do as many flags as you can. They came back and they said, that was one of the best assignments that I've ever done, right, at the academy. So wherever Clayton is, thank you very much for writing that challenge. And my perception is that the students are really enjoying it. The engagement has gone up, the grades are really good, and the students are putting in a ton of effort, right? And so this is, and the level of achievement that I'm seeing on their final projects is very much in line with what I would want to see for cadets who are doing no-kidding research and able to publish. So we have a couple of comments here. Oh, I actually got an email from a cadet who graduated and said, hey, my boss is amazed at what I know how to do with software-defined radios because of your class. And so I was like, wow, I feel justified in what I'm doing, right? And this is really what I want to do. And I'm not done, right? We still have a lot of challenges to overcome, to include student laptops come in varying states of disrepair. Some of them have Windows and some of them have Windows that don't work. And we have a variety of different operating systems that we have to deal with. And so we're still working on a software baseline that makes sense. I think I still got some tweaking to do on the organization and how we order the classes. And of course, I need to make sure that I'm keeping ABET happy with some of the things that our first course provides, like applications of probability and statistics. So like making sure I really hit the noise and the random signals in enough detail to satisfy that requirement. Those are the things that I have to do. So thank you very much. I appreciate you sticking in with me. I think I got my 30 minutes in. And yeah, are there any questions?
OFDM in your course?
Yeah, so usually that falls under the special topics, even though I know it's not a special topic. And sometimes we hit it with the HD radio because those sidebands have OFDM encoded data. So yeah, great question. And definitely something that they need to understand when we talk about next G systems, right? Yeah, Wi-Fi.
Wi-Fi, 4G, it's all OFDM.
Yeah, absolutely, yeah. And that's something I definitely try to, and there's, again, GNU Radio has a great tutorial on that, so very useful stuff.
Great talk. It's like music to my ear. My question is regarding like your course material that you have prepared. When you actually go ahead and teach this in your class, are you teaching a theory first and then you are designing lab that goes with the theory, or the lab is the primary thing you want to teach and then your theory is sort of around that?
Yeah, so we start with the theory and we want the lab to back that up, right? So we started with the theory of like AM, for example, and then we pull in the traditional lab, and then I pull in the GNU Radio lab for them to be able to tie all three of those together. Yeah, so then we have theory, lab, and kind of simulation all working together.